Okay, so let's get this started. So we'll go to a new project. So we're going to learn about inheritance today. Okay, so this is a sort of a somewhat advanced object-oriented concept. Okay, so what inheritance allows us to do is create is-a, quote-unquote, is-a relationships, like ISSA, right? Or ISA, is-a, right? So for example, we've been defining a class called car, right? That will have properties and methods that are common to all types of cars. Okay? But what if we wanted a class that represented sports cars, right? Sports cars are a little more specific. They have some properties and methods. They can do things that not all cars can do, right? Or let's say if you had a, what's another example of a car? A different type of car. Truck. Okay, that kind of falls outside my, because a truck is not really a car. If the superclass was vehicle, then yes, that would make more sense. But let's stick with car. So maybe we could have what kind of car? That's specific. So maybe an electric car. Well, actually, that would be a property. I think sports car and let's say, SUV would probably be okay, and that's another type of car. And let's say maybe taxi cab. That's a specific type of car. That's a good one. Taxi cab. Okay, so so what we'll do is we'll recreate our what's called the superclass. Okay, so the superclass or the base class holds the most general definition of your object, right? So so let's just create this object. Okay. So your base class or superclass will hold everything that's general to all the objects, right? So when we created our car class last time, we gave it properties that all cars have, right? All cars have a color. You can't have a car without a color. It doesn't make sense unless it's clear, but even then it's still a color technically, right? But let's say a taxi cab has things that a sports car does not have. Okay? A taxi cab will have, let's say, the meter. You can start the meter in a taxi cab, right? But other cars, a sports car or an SUV, they don't have that meter, right? And they also, a taxi cab would have a property called current fare amount, right? Where an SUV or a sports car, that wouldn't have that, right? So what we do is we don't store that information in the superclass. We put that in what's called the child class. And the child class inherits all the common properties from the parent or superclass, right? So think about humans and genetics, right? You inherit traits from your parents, right? It goes downward. So if your dad is pretty tall, you'll probably be pretty tall too, right? You're inheriting those properties from the parent, okay? So it works a little bit differently in programming, but just remember that the inheritance goes down, right? Your parents don't inherit things from you, right? It's the other way around. You inherit traits from your parents, okay? So let's create our class. Let's recreate our class, okay? So how do we do that? So we create a new item, and then we create a class, and let's call it car, okay? So our car is going to have a constructor method, and how do we determine if it's a constructor method again? That's true, but also it's named the same thing as the class. Okay, and so convention says we should capitalize the first letter of our class. Okay, objects will have lowercase, so when we instantiate our objects, use lowercase. When you have a class, use uppercase. Okay, and then it helps you to differentiate so that you know when you're referring to a class and when you're referring to an object. Okay. So what were some of the common properties of the class car? Yeah, so, and that was string, right? So color, and what were other common properties? Yeah, string, make, string, model, int, year, yeah, string, fuel, type, what else? Yeah, top speed. All right, let's make that a double, actually. And we'll also have current speed. And what? Yeah, engine size. We'll make that a double. Engine size. What else? Yeah, transmission type. So we'll make that a... What's that? Sure. Yeah, okay. Acceleration rate, and mileage, and one more. What was the other one? Someone else mentioned one? Sure. Wheel size. Okay. So there's a few more that we're probably missing, but this is okay for our demonstration purposes. Okay? So, yeah, that's good enough for property. So let's think about methods now. What were the methods of our car? What are the methods? Yeah, so accelerate. Okay, accelerate. So we'll call that public void accelerate. Okay, and what do we need to pass into that method? Yeah, the rate. So double the rate. Okay? And what else do we need to do with the car? What else does a car do? Turn? Oh, yeah, okay. Public void turn on headlights.
What about brake?
That we could take care of in accelerate, because if we want to brake, then we just negatively accelerate. So another one might be turn car, and what would we pass into that? No, but if we're going to turn a car, what do we need to know? Yeah, how much you're going to turn it. So we need to know the degree. Speed? How do you mean? Okay, so, well, what you might want to do then, when you turn the car, is you might want to say, if current speed is above, let's say 100, then you might want to say, oops, you crashed. Oops, I have to include Windows Forms in my class. See that? I added system using system.windows.forms in order to use message box. Show, and then I might say you crashed. Okay, but let's think of one more method, and then we'll move on. We'll create our child class. What's one more method, maybe? So maybe, how about we do void use turn signal. And what do we have to pass into that method? What information do we need to know? Well, when you turn on if let's say I'm the passenger and you're the driver, and I say, turn on your turn signal. Right or left, yeah. Direction. So we could probably do that with an int, I guess. We could use a bool, but I don't know if it makes as much sense. Okay, so we have. So let's fill out our class a little bit now. So let's say when we'll just print out messages. So when we accelerate, what we'll do is we'll say current speed equals current speed plus rate. Okay, and then we'll say int current speed is an int. So let's change current speed to a double, because that should be a double. Okay, and then what we'll do is we'll say message box show, and we'll print out you are traveling at, and then we'll add in the current speed, and then we'll add in another string, kilometers per hour. Okay? So then, for turn headlights on, we're going to need to add another property. So let's add a bool property called headlight on. Okay? And when we initialize our constructor, when we initialize our object using the constructor, we'll set it to be false. So that's going to be its default value. Okay, so now what we do is we're going to check. We'll toggle it. So we'll say if headlight on, then, so if it's on, we're going to turn it off. If it's off, we're going to turn it on. Equals true. And then else headlight equals false. And then we'll say we can message here. We'll say message box dot show the headlight is now on, and then we'll do the same thing here, except we'll say the headlight is now off. Okay? And okay, let's leave that for now. I want to get ahead to the actual inheritance part now. Which part? Headlight? This one? Yeah. So if the headlight is on, oh no wait. So if headlight is true, then we want to turn it to be false. Else we'll turn it on. So we just have to change this now. Sorry, I had that reversed. So if headlight equals true, because headlight's a boolean. Headlight is a bool value, and we're initially setting it to be false, right? Because a car, it doesn't come automatically with the light already on. So then we check if the light is on. So if it's true, then turn it off and say the light is now off. Else,
if headlight on equals true,
because it's already a boolean. So if you have, let's say we had something like this. 5 equals to 5. That statement resolves to true or false. But because we have a boolean statement, that is already equal to true or false. So this is equal to this, like that. Right? So right now, the value of headlight is false.
so you're saying if it's false, then again make it false.
No. But in this case here, no, I'm saying if true, so if the headlight equals true, then change it to be false. And if it's not true, then it's else, it's going to be false, so then turn it on, make it true.
We don't have to write true.
Where?
Like the first if statement.
Well, we could say this. If headlight equals true, we could do that, but that's redundant. That's like saying Like the value of headlight is already true, so it's saying if true equals true. Like it's just shorter to put this. I mean, we can have this though. This would work.
So the default value is true, right? So like,
What's that?
so for any bool, the default value is true.
No, but we don't have to. It's already a Boolean statement, right? This here is a complex statement that gets resolved to either true or false. But if it's a Boolean value, it's already equal to true or false, so there's nothing to resolve. You see? So this is the same as this, because it can only equal true or false. Okay? So the default value is whatever we set it to be. We set it to be false when we create the object, right? Okay? Okay, so is everyone caught up to that? I'll give you a minute. Let me see if you guys have that.
You need to get a mouse. Don't use the trackpad. It's horrible. You need a mouse. A mouse is, they've scientifically shown it. It's the better input device. There's no, you can't argue about it. You need a mouse. And they're $5. Go to a computer store. Get one. $5.
$5 what?
For a mouse.
Oh. Alright, so...
Can't use the trackpad for serious stuff. That's only in a pinch, right?
So how's mine going?
Looks good. Looks good. Good. Okay, so now what we want to do is, so let's instantiate our class. Okay, so we're going to go to our form, and we're going to create a button, just so we can initiate some action. And then we'll double click on our button, and inside our button, what we're going to do is we're going to create a new car object. So we'll say car, my car, equals new car. Okay? So now I can do things like this. I could say my car dot turn on headlights. Or in this case, you know what we should actually, because we're toggling it, it shouldn't be called turn on headlights. We're going to change the name to toggle headlights, because that's a little more appropriate considering what we're doing in here. It's not just going to turn it on, it's going to toggle it. Okay? So we'll save that, and then we'll go back to our code, and so now this is undefined, and we'll use the toggle headlights. Okay? And then we can toggle it again. So, and let's run it now, and let's see what happens. Okay? So now we can press our button, and it says the headlight is now on, the headlight is now off. Okay? So now we've instantiated our class and called one of its methods.
Did you set it to true or false in first?
So what I did was in the car class, in the constructor, I set headlight on to be false.
Yeah, but it's both false when I run it.
Well, maybe is your toggle headlights function okay? Headlight on. Oh no, see, yeah, because this should be, you should switch it around. So yeah, put this in here and this up there. Wait, why? Because so if it's true, you want to make it false. Else, make it true.
Whoa.
Yeah. And then also then you want to change the message to off. Okay. Okay. So
I don't get why it's up.
because well, if it's true, then make it false. That's how the toggle would work.
Oh, toggle. Oh,
There's your toggle.
oh, we're not checking it. We're toggling.
Yeah. Okay. So now what we're going to do is
Why do we have to use the constructor thing? Because to toggle it to false in the first place.
Well, that's
it's
the-
already false anyways. It's already false anyways.
well, not if we don't initialize it.
No, but it's already false just by just by defining the instance.
By defining it, it's not false. It's null. You have to give it a value.
Oh, I thought. Oh, Java it's actually like.
I don't think so. You have to declare the value. Declaring the variable and setting the value is two different things. Okay, so now what we're going to do, we're going to create a new class. Okay? we're going to create our child class, and we're going to have it inherit from the parent class. Okay? So we're going to create we're going to add a new class. There's actually a shortcut right there. We can do that. And we'll call it taxicab. Okay? That's going to be our subclass or our child class. Okay? Okay. So what we're going to do, we want taxicab because taxicab has all the things that a car has, right? A taxi has a color, and a taxi has a make, and a taxi has a model, and a taxi has a year. It has all of these things, right? So what we could do, we could copy and paste all of these. I could copy these properties, and I could paste it in our new taxicab class. But don't do that. That's a waste. That's a waste of time. We don't need to do that. Okay? All we need to do now is inherit from car. So the way we do that is after we declare our class taxicab, we put the semicolon there. Okay? And then we give it the class that we want to inherit from. Well, for now, yep. So now let's take a look at this. Let's go back to our form. And so now what we can do, we can create a new class called taxicab, and we'll call it cab equals new taxicab. Now, what's really cool now is that cab will have all the functionality that car has, right? So we can toggle the headlights. Right? We can, and let's do it again. Toggle the headlights. Okay? So see now, if we actually go and look in cab, there's nothing here. There's no code here. But what we've done, because we've inherited from car, it's almost like all this code that's here is also now here in taxicab. So when we went here, and we declared a car, and we called toggle headlights, but we also declared a cab, which also has toggle headlights. Okay? So does everyone have that? Did everyone create a new class and extend the car? Great.
Except that you don't know if it's well, you don't know if it's gonna be from the car or from the cab. It's toggling it based on this code, right?
Well, what do you mean? It's running.
Yeah. You don't know if it's the car that's the headlight of the car or the cab is on.
But we know because we're referring to a specific type of object.
Oh yeah.
Right?
Just by the user looking at the message box, they would know.
No. What we can do, though, is we can actually override methods. And I'll show you how to do that in a minute. Okay. So what we want to do now is let's add in an extra method and an extra property into taxicab. Okay? So what we're going to do now, so what's a property of taxicab that taxis have but other cars don't have? Yeah, the meter, like the current fare, right? So let's see. So we would call that double, and we could call it current fare. Okay? And then what method might we have?
Increase fare?
Yeah, or like start trip. Start trip or start fare. Right? So it would be so public void start.
I have a few questions.
Yep. Okay. Start
If
trip.
those variables are private in the car class, does taxi cab have access to those variables?
Not if they're private. If they're private, it doesn't have direct
For
access.
inheritance, though.
No, still. If it's private, it won't. If it's protected, so there's private, protected, and public. So public will be accessible. So if it's private, it's only accessible in that class. If it's protected, then it's accessible in that class and all classes that inherit it.
Oh.
If it's public, it's accessible in the class, in the inheritance, and outside of the class.
Yeah.
Okay?
So that's why you didn't set private in the first place for this.
Yes. So it would have to be, well, if you set it to private, then I wouldn't be able to access it in my subclass. Okay? Okay.
And no constructor here.
It's using the parent constructor. So remember, all those methods are, it's like the methods are here, right? Okay. So, and then we need one more method. Let's call it public void end trip. Okay. So then we might have, so we need to copy, will we have? No, we won't have access. So we need to still include this. Okay, so we can access our Windows forms inside our new subclass. So we'll say message box.show.
Do you have to paste it every time you create a class? Copy paste this thing?
This?
Yeah.
Yeah, if you want to use message box, yeah.
If
Yeah.
not,
No. Message box show so trip started. Okay? And then here we'll say trip ended. Okay? And I don't think I'm not going to show you a timer right now. Okay, so now let's go back to our form. So if we go car, my car, right, there is no start meter function. Okay, but if I go to my cab, there is start trip. So we have cab now has all the methods of car, but it also has an additional bit of functionality.